Hello everyone. So previously we had discussed on the designing a rate limiter. Yeah. So today we'll be discussing how to design a load balancer, right? So let's go through the question first here. Design a load balancer system that distributes client requests among multiple backend servers based on the different algorithms such as round robin, weighted round robin, and least connections while supporting dynamic server management as well as the simulated health checks. Yeah. So this is the question actually. Let's go through the this one actually. Functional as well as the non-functional requirements first. Yeah. So this is the question. I hope the question part is completely clear, man. So let's discuss about the functional requirements here. So first thing is accept incoming client requests and forward them to the backend servers and forward them to the backend servers. So this is fine. The second one is support multiple load balancing algorithms. Support multiple load balancing algorithms. Yeah. So this is also important. Next, maintain server health status. We have to maintain the server health status, right? So for the fourth one is dynamic server management. Yeah, when I say dynamic server management, we should be able to add or remove the servers and change the weight at runtime. Yeah, so we should be able to add or remove servers and change the weights at runtime. Yeah, this one we have to keep in mind. Next one, so collect this one basic matrix. Yeah, collect basic matrix. So this is fine. Dynamic server management. Collect basic metrics in the sense. So we have to check per server active connections as well as the total requests served, right? So finally, let's move on with the last one here. Provide an API to query server pool status and metrics. We should be able to provide an API to query the server pool status and metrics. Yeah, let's move on with the next one. Nothing but non-functional requirements. Let's move on with the next one. Nothing but non-functional requirements, right? So the first one here would be high throughput. Yeah, high throughput as well as the low latency for routing decisions. When I say high throughput and the low latency for routing decisions, it's big of one or amortized big of one per request. See, I'm speaking of the big of one or the amortized big of one per request, right? So then comes the fault tolerance. So what's the fault? What's fault tolerance here? So we should be able to tolerate some backend server failures without dropping the client requests. Yeah, this is one of the things. Next, let's move on with the scalability here. When I say scalability, we should be able to support horizontal scaling, meaning we should be able to this one handle multiple load balancer instances behind DNS or any cast, right? So this is fine. Next, let's move on with the observability here. Observability in the sense, so here we should be able to expose the metrics and health events for the monitoring purpose. Yep. The final one is concurrency safe. Concurrency safe in the sense here, so we should be able to handle many concurrent client requests, right? So with the correct metrics, with the correct metrics. So these things we should be able to do. Yep. Now let's move on with the algorithm selection. So the one of the important things here is to go with a particular correct algorithm, right? So to go with the correct algorithm. So first thing here is round robin. When I say round robin, so you should be knowing the round robin. We have already discussed the round robin algorithm. So we should be knowing the round robin algorithm by now. So this is simple, fair when servers are identical because this one. So when servers are identical basically, and also because one per request and good default, right? So also we can just extend this one by making use of weighted round robin. Weighted round robin, what it does actually, it extends round robin to account for the capacity differences using weights, right? Slightly more state or complexity. Yep. So this is fine, man. Yep. So this is about the round robin as well as the weighted round robin. So we'll be going with the round robin itself. Yeah. Yep. Now, also least connections. When it comes to this one, round robin, least connections in the sense, so basically we are able to forward to server with the fewest active connections, right? So this is good when requests have variable duration. Yeah, when the requests have variable duration, right? So basically it requires a minimum heap or the minimum priority queue or tree for the this one logarithmic n selection or approximate big of one with a sharding, big of one with sharding, right? So this is fine, man. And also, when we make use of the round robin, we can just go with the consistent hashing as well, right? For the session affinity or the caching, we can just go with the consistent hashing, right? Basically, routes based on this one client keys to reduce cache misses. When I say session affinity, right? So it is also useful for sticky sessions, but let less balanced if servers change frequently. And also it's hybrid actually. We can make use of the round robin for the most traffic and least connections for heavy long requests. Yeah, that is also one of the this one pros actually. Yeah. So basically round robin is the simplest all is the simplest one. Also it consumes this one how do we say lowest CPU actually. Yeah. So basically when I say we will be going with the least connections, right? Least connections is equivalent to the better for variable load, right? But for more state or complexity. So weighted algorithms requires when heterogeneous server capacities exist. For this, we'll be going with a round robin. Also, we can just make use of the weighted round robin. Let's see. Yeah. So now let's do one thing. Let's move on with the concurrency part as well as the data model. Yeah, concurrency part as the or the data model or concurrency and data model, right? So first data model. Let's go with the in-memory view, right? So let's go with the in-memory view here. In-memory view in the sense, let's go with the server object. Server object in the sense ID, address, wait, active connections, total requests, healthy flag as well as the last heartbeat last heartbeat. Yep. So also let's go with the server pool or the load balancer. When I say server pool or the load balancer, um, it holds the list or the dictionary, nothing but dict of server objects, right? Indices also it holds the indices for the selection algorithms, logs as well as the metrics as well as the metrics. Yep, this is fine, I believe. Now let's move on with the concurrency model as well. So we will be using the fine grained locking per server here for the active connection, for the active connections, increments or the decrements. Basically that reduces the contention. That is the reason. Yeah. So also we will use an atomic pointer or the index, right? When I say we'll be making use of the, this is fine. When I say we'll be making use of the atomic pointer index for the round robin selection, right? So basically we'll be going with the round robin selection, right? So we'll be making use of the atomic pointer or the index or the thread safe counter, right? For the round robin selection, basically this is fine. Next, frequent health checks. This one frequent health checks, basically it runs in the background worker threads and update the healthy flag under lock. So this is fine as well. Now, so we have to ensure for high throughput, right? So when I say this, we let's say in this way, let me put it in this way. We prefer log free counters, nothing but atomic, where language supports, or we can just make use of the sharded pools to reduce the log contention. Yeah, for the high throughput actually. Final one is we have to ensure the request routing and the metrics update are consistent. Yeah, meaning we have to increment the active connections before forwarding. We have to increment active connections before forwarding, right? On response, on response or simulated completion, we have to decrement the active connections, right? So this is it for the this one. What do we call concurrency model actually? Yep. Now let's before moving on with this one UML diagram, let's discuss the failure modes and mitigation as well. Yeah. When I say failure modes and mitigation, if the health check marks a server dead, suppose if the health check, whatever health check we are doing, if it marks a server dead, we have to remove from the selection sets quickly and drain them or and drain existing connections. Yeah. Or allow them to finish. Yep. So that's the one thing that we have to keep in mind. Also, just think of it. We can just make use of the timeouts as well for the backend connections to avoid the indefinite blocking. That one also we can do. And for the stateful sessions, we can just make use of the sticky sessions with a consistent hashing or external session store or external session store. Yeah. So this is it for the this one failure modes and the mitigation. Basically, this is it for the concurrency and the data model discussion, right? So next, let's do one thing. Let's go with a simple, or let's discuss the UML diagram. Yep. First here, we have the load balancer, main one, main class actually load balancer. And here we have the server's dict. it algorithm, this one decision, and round robin index, or a round robin index, right? So these are the helper methods: route of request, add server, remove server. So we should be able to add the server. So these are the routes actually: route of request. We should be able to add servers, remove servers, as well as the health check. So this is accordingly with the criteria that they have given in the question. We have discussed this one functional as well as the non-functional requirements as well. Yep. So this is fine. Now let's move on with the servers, actually servers of dict, whatever we have considered. So under this, we should be able to, or we will be going with the actually ID, address, weight, active connections, healthy, because we are going with a health check as well, healthy. So, and finally we'll be going with a handle of a request. So this one, handle of request method. Yep, under the server. So this is fine. So the same thing will be articulating in the form of code, right? So I have shown you the UML diagram. The same thing will be articulating in the form of code. Yeah, let's do one thing. Now we have the idea. We have already discussed most of the things, right? Now, actually, let's do one thing. Let's go with a round robin, weighted round robin, and the least connections selections actually. Yeah. So also let's go with a server health check simulation and the concurrency safe increments or the decrements of active connections using threading. Let's make use of the threading as well as this one logs actually. Along with the threading, let's go with the logs as well. And finally, let's go with a small simulated client workload just to show the output. Yep. Let's do these things actually. Let's start writing the code. So first, let me import here threading actually. So this has to show. Yep. Now let's import the time as well. So I'll just go with import time. Yep. Next, uh, let's import random as well. We need random. Yep. Also, let me do one thing. Let me go with from collections. We need the DQ, right? So I'll just go with import DQ. Yep. So this is also fine. The final one is from typing. Yep, from typing, let's import. What are the things that we need actually? Dictionary as well as the list, right? We'll be importing dict as well as the list actually. Yep, dict as well as list. This has to show. This is not showing. This is fine now for showing in the suggestions, right? First, let's go with a class server, right? Class server. So I'll just go with server here, right? So just give me a second here. Yeah, within the class server, let's do one thing. Let's move on with the initialization part of the constructor part here. So I'll just go with the def init. So let me remove this one along with the self. Let me go with ID, which is of the type string. Also address, uh, which is of the type string here. And also let me go with a weight, which is of the type int. Let me assign this one to the one. So this is fine. So within the initialization part, so let's do one thing. I'll just go with ID equals ID. So this is fine. Self dot address equals. Let me go with address. What happened here? So this one. Yep. Now this is fine. And we are going. Let's initialize weight as well. Right. Just go with the weight. Let me initialize this one to the weight. Also, I'll just go with a active here. Active connections, right? So what happened here? Active connections. I'll just set this one to 0 initially. And let me go with the total requests as well, right? So I'll just go with the total requests. So let me initialize this one to the 0. And also healthy, let me initialize this one to true. And finally, let me go with lock. So this one threading dot, I'll just go with lock. So this is fine. Yep. We have to mention the parenthesis as well. Now, let me go with the function acquire or helper method acquire here. So I'll just go with acquire here. So let me make use of the cell. This is fine. So within the helper method acquire, I'll just go with um, lock actually. log. Yeah, this is fine with log. So let's set the this one active connections equals active connection plus one. Also for this one total request equals total request plus one. Yeah, simple. Yep. So I'll just go with a self dot active connections. This has to show. Yep. So active connections equals active connections plus one. And also let's go with the total request equals total request plus one actually. Yeah. This is fine. Now we are done with the helper method or the function acquire. Now let's move on with the release actually. Yep. I'll just go with release here. Let me pass self. Yep. So within the release helper method, I'll just go with self. So just give me a second here. Log actually. What if the active connection is greater than zero? Then we have to go with active connection equals active connection minus one. Yep. So I'll just see here. I'll just write here. Sorry. Active connections, active connection. If it is greater than zero, then active connection equals active connection minus one. So this is fine. Now let's go with a helper method. This one mark unhealthy. Right. So I'll just go with a mark unhealthy. Yep. So let me pass the self as well here. So let me go with self log. Yep. So with self dot log, let me go with self healthy. Healthy. Let me assign this one to the false. Let me assign this one to the false. Right. So next, we have went with a mark healthy, right? So sorry, unhealthy, right? So now let's go with a mark healthy actually. So I'll just go with def mark healthy here. So let me pass self as usual. So this is fine. Within the helper method, mark healthy or the this one function mark healthy. So the same thing, I'll just go with here with log actually. Yep. Let's set the healthy to true here instead of false, right? So let me copy this one and let me paste it over here. Instead of the false, if healthy, we have to set this one to the boolean value too, right? So this is fine. The next step would be, let's go with a snapshot actually. I'll just go with def this one. Snapshot, pass the self here. So this is fine. So within the snapshot, so I'll just go with again the same thing with log actually. Yep. So what shall be written? Let's return certain things here. ID within the strings actually. Let's set this one to the self dot ID. So this is fine. And address. What happened to this one? Yeah. I'll just set the address to the this one address. Right. So this is fine. The next one would be let's go with a weight actually. And let me set this one to the this one has to show self dot weight. Yep. What are the things that we considered actually ID, address, weight, active connections, total requests, as well as the healthy, right? So let's go with the active connections. So let me copy this one here and let me paste it over here. Yep. So this is fine. Self dot active connection. So this is fine. Next, let me go with along with active connections. We are going with a total request. So this is fine. Let me paste this one over here. Total request. So I'll just go with self dot total requests. Yeah. So this is fine. The final one is healthy. Yeah. So let me copy this one and let me paste this one healthy. So I'll just go with self dot healthy. Yep. So this is also fine. Yeah. So I'll just come out of this one entirely. Now let's go with a main class actually. Main class, nothing but. So these all the things come under the server class, right? So whether it may be acquire, helper method release, this one helper method mark healthy, as well as the snapshot. The helper methods are the functions that come under the this one server class. Now let's go with the main class, nothing but the load balancer, right? So I'll just go with a class here, load balancer, right? So this is fine. What will be the first thing? So the first thing will be the initialization or the constructor part here. So I'll just go with init. So this is fine. Here, along with the self, let me set the algorithm to this one. What do we call? A round robin here. I'll just go with round robin. Yep. So this is fine, I believe. Yep. Uh, what are the things that we need to this one? What do we call? Initialize here. Basically, I'll just go with the servers. So if you look at the this one UML diagram, so we had considered that one, right? Servers will be making use of the dict actually, right? So I'll just go with the dict here, set dot server. So dict of I'll just pass here str, nothing but the string, and let me give server here, right? So this is fine as I'm making use of the dict. So this is fine. Next, let's go with the log. So I'll just go with self dot log here. Let me assign this one to the threading dot log. So yep, sorry, capital L. Yep. So this is fine. So what's this actually? We are basically protecting the server's dict and wait structures here, right? So by making use of this threading dot log. So this is fine. Now I'll just go with algorithm. This is not showing. Let me type this one. Self dot algorithm. So let's set this one to the algorithm. Yep. So this is fine. And self dot what is the thing went with a round robin index. If you just observe the UML diagram, right? So let's go with a round robin index as well. Let me initialize this one to 0. The final one is weighted weighted queue, right? So I'll just go with self weighted queue, right? So let me set this one to the DQ, right? So let me set this one to the DQ. Yep. So next, let's move on with the functions. Let's move on with the helper methods of the functions. Weighted queue, the last one is this one. Uh, this is nothing but the pre-expanded list for the weighted round robin actually. Yeah, we'll be going with the extended round robin as well, right? Along with the round robin. So that is nothing but the pre-expanded list for the weighted round robin. Next, let's continue with the helper methods for the functions basically. Let's go with the first helper method. Let's go with the add server. So as discussed, if you observe the this one, if you see the UML diagram, so first method is the add server. Let's go with the add server here. So this one will be, let's set the server to the server actually. Yep. So this is fine. So within this helper method, so I'll just go with log actually as usual with log. So I'll just go with servers servers of this one server ID, right? So let me go with server.id here, and let's set this one to the server. Let's set this one to the server, and also let me go with a rebuild here. Mm, just a second here. Rebuild. Let me go with weighted queue. Let me go with weighted queue. Yep. So this is fine as well. Yep. The next thing would be, let's go with remove. Let's go with the remove server here. Hmm, let me go with let me set this one server ID of the type string actually. So this is fine. Yep. So within this helper method, remove server. So first, as usual, let's go with a with lock actually. This is not showing. Oh, we have to make use of the self, right? So going with a class actually. This is fine. Yep, with self dot lock. So first thing, if server ID in servers actually. If server ID in servers. Yep. So this is fine. Then, sorry, one has to be if actually. Yep, so this is fine. The next step, so let's go with the delete here. Uh, server, servers actually. This is not showing. Let me type. What we need to delete, we have to delete based on the server ID, right? So this is fine. Next, let me go with a rebuild actually here. Rebuild weighted queue. Not showing again. So let me copy this one. So let me paste it over. Yeah, rebuild weighted queue. Let me make use of the parenthesis here. So this is fine. We are done with the helper method remove server, right? Adding the server, removing the server. Then if I remember this one within the UML diagram, we went with a rebuild weighted queue as well, right? So let me continue with the helper method rebuild weighted queue. This one. Let me copy this one entirely. Paste it over here, right? So also let me pass self here. We need self anyway. So let's build the sample repeated list according to weight for demonstration. Yeah. So I'll just go with self dot. mm, Let me go with the weighted queue here. Let me make use of clear. Yep. The next step would be for sn self dot servers dot values here. This is fine. Yep. If s dot healthy s dot healthy, then what shall we do? We have to add the server ID wait times, right? So we have to add the server ID wait times, meaning this is capped to avoid huge lists actually, right? So I'll just make use of cap equals. Let me set this one to the min of s dot wait. So along with the, let me set this one to the 10. So this is fine. Yep. Next, after capping it, let's move on with the for loop here. For in range actually, what would be the range here? So let me pass the cap here. So this is fine. Next step would be dot. I'll just go with the weighted queue here. Yep, weighted queue. Let's append server ID. S dot ID we have considered, right? So I'll just go with append here. So let me pass S dot ID. Yep, the simple one. We are done with the helper method rebuild weighted queue, right? So now let's move on with the set algorithm actually. Set algorithm helper method. So I'll just go with here def set algorithm here. Let me pass the self as well as algo, which is of the type string str, right? So now within the helper method, within this helper method actually, I'll just go with lock. Let me go with the lock. Then what shall we do? I'll just go with algorithm, self dot algorithm. Let me go with algo. Yep, let me go with a algo. Also, let me go with round robin index. Let me initialize this one to the 0. Let me initialize this one to the 0. Yeah. So this is about the set algorithm. Next, let's go with the this one. Get healthy servers list actually. Get healthy servers list helper method. Yep. This one, let me pass the self here. This is fine. Let's go with a list of servers. Let's go with a list of servers or server. So we have to go with server, I believe. We go with a server. Yeah. So within this helper method, I'll just go with again the same thing with lock actually. Yep. What we need to return here, I'll just go with return s for s in servers dot. We have to go with the values, right? I'll just go with the values here. If s dot healthy, this has to show. Yep. So this is fine. Till here, I hope everything is fine, right? Everything is clear, I believe. Yep. Next, let's move on with the after going with the or after dealing with the get healthy servers list. Let's move on with the select server. This one, select server helper method. Yeah. So I'll just go with def select server. So this is fine. Let me pass self here server. So this is fine. Next, let's move on with or let me set the healthy the self dot. Let me make use of the get healthy servers list. Mm, 1 second. We are going with selecting the server. This is fine. Get healthy servers list. Yep. Let's go with the get healthy servers list. So this is fine. Let me write the simple if condition here. If not healthy, if not healthy, then let's return none. We don't have to return anything. So I'll just give here return none. Yep. So this is fine, I believe. Next, let's move on with a simple if condition here. If self dot algorithm, so we have to type, I think, completely algorithm equals what's the algorithm name we have considered? Round robin, right? So let me copy this one. Let me paste it over. Yeah. So this is fine. If it's round robin, then let's do one thing. Let's go with a simple round robin here. Yeah. Index modern, right? So I'll just go with sorry. So why this is showing like this? 1 second. If oh yeah, we are checking, right, if it is equivalent to. We have to make use of the comparison operator here. Now let's go with a simple round robin here. Index modern, as I've said, right? So I'll same thing with lock actually first. Yep. Let's move on with the algorithm actually. Let me set the index to the what I've considered RR index itself, right? So yep, modulo length actually length of let me pass the healthy here. This is fine. Yeah. Now this one round robin index equals round robin index plus one we have to go with further for the further operations, right? So I'll just go with self round robin index. Yep, equals round robin index plus one. Yeah, so this is fine. Finally, let me return here. What we need to return here? Healthy of IDX, right? So I'll just go with a healthy of index. Yep. So this is fine. Let's do one thing now. Let's go with a what if we want to make use of the weighted round robin as well? Yeah. So else if I'll just go with the else if here algorithm here if it is equivalent to weighted round robin. We have selected the weighted round robin, right? Where is the weighted round robin? So let me copy this itself. So this one, let me set this one to the round robin. Also, let me give here weighted round robin. Yep. So this is fine. Mm, so within this one, elif actually. So again, the same thing. But first, let me mention this one. Yep. With lock actually. If not, self dot weighted queue, right? So yeah, if not weighted queue actually, then let's set the rebuild weighted queue, right? So I'll just go with let's call the this one rebuild weighted queue. Yep, so this is fine. The further step is if not sell this one weighted queue actually. So we have went with the this one, right? 1 second. Yeah. If not, let me go with weighted queue here. Then let's return none. Then let's return none. So this is fine. Next, let's go with a server ID, nothing but SID. Here, I'll just go with self dot weighted queue, the first index, nothing but the zero here, right? Now we have to rotate. For the rotation, I'll just go with self dot weighted queue dot rotate. Let me go with the rotate of -1. So this is fine. Finally, we have to get the this one. What do we call server ID? So I'll just give here a return, just pass here servers dot get of server ID, nothing but SID is the variable that we have considered for that. So this is fine, man. Yep, let's do one thing now. Hmm, let's write one more elif instead here. Yeah, so I'll just go with the elif here. Algorithm, if it is one more algorithm, we considered least connections, I believe, right? So I'll just write here least connections. What if the round robin? What if this one, weighted round robin? Next, we have considered what if the least connections algorithm, right? So this is nothing but big of n scan, right? So this will be okay for the small n. Okay, this will be okay for the small n or suitable for the small n, right? For large pools, we have to make use of the heap or buckets. Just remember this one, yeah? So let me make use of chosen here. Chosen, let me set this one to the mon of healthy, mon of healthy, key equals, let me give the keyword lambda here. This is fine. S dot, let me go with S dot, let me go with active connections. Yeah, now this is showing, this is fine. Yep, the next step is we have to return chosen. Yeah, chosen is the keyword that we have made use of, so let's return chosen here. Finally, let's come to the else part here. Else, let's set the default to round robin, the first one that we have written, right? So I'll just give you a return random dot choice. This one has to show. This one has to show actually. This is fine. Random dot choice of healthy actually. Yep, nothing but the we are just setting the default to the round robin here. This is fine. We are done with this part, man. Finally, let's move on with the next helper method actually. One second. Yep. Let's move on with the next helper method, nothing but a route request, if you remember. Yeah, we have to go with the route request, handle request, as well as the health check cycle, right? So then we can finally go with a snapshot, these four methods, right? So, yep, let's do one thing. Let me type this one, one by one actually. This is fine. One second. Yeah, let's move on with the route request. So I'll just go with the route request here. Let me go with self. So this is fine. Let me go with the request ID as well. This is also fine, which is of the type int. And let me go with duration here. It so which is of the type float actually. Let's initially set this one to the none. So this is fine. So within the helper method route request, so first thing is let's set the server to the select server, right? So let's set the initially we have to set this one, select the server, right? So I'll just go with select server, right? So this is fine. This is the reason we have written the this one class server basically, right? So if not server, if not server, so this one has to be kept smallest. This is fine. So this one, what's wrong here? We haven't, we have select. Oh, this one I have. Sorry, this is fine. Let me come here. If not server, actually, this one. Now this will be good. So let's go with a print statement. Let's print something for the interactive purpose, right? So I'll just go with here print. What shall we print? We'll be making use of the string interpolation. Let me start with the F here. So I'll just go with LB here, LB. So let me give here no healthy servers for request. So this is fine. So let me pass the request ID. This one based on the request ID, right? So this is fine, man. Finally, let's do one thing. Let's return false, right? So I'll just return here false. Let me go with false. So this is fine. Yep. Now what shall we do? Now what shall we do? We have to simulate the acquiring connection. So let's do one thing. I'll just go with server here dot acquire, server dot acquire here. So this is fine. The next step is again, let's move on with a print statement here. So I'll just go with F followed by this one. LB, this is fine. Routed request. Let me pass the this one. What do we call? Request ID. So this is also fine. Server. Mm, this one will be server. So this is fine. Let me go with the server ID. Yep. And let's set the active. Let's set the active equals server active connections. So I'll just go with the active connection. Right. So this is fine, man. Let's move on with the further things actually. So here t equals threading dot thread. This is fine. Uh, Let me move on with the here. So let me go with target equals self dot. So let me go with handle. mm, Handle request actually. Yep. So let me select the arguments to here. Let me go with server. Along with the server, let me go with the request ID as well. And let me pass the duration as well here. So this is fine. So let's set the this one daemon actually to the true. Let's set the daemon to the right. So after setting the daemon to the true, let me go with thread dot start actually. Yep. So this is fine. Finally, let's return true. I'll just go with return actually. Yep. So this is fine, I believe. Now we are done with the basically what do we call route request helper method. Now let's move on with a handle request actually. I'll just go with def handle handle request. So let me go with self. Let me go with server. So this is fine. Let me go with request ID. Let me go with int here. Let me go with duration. Duration. Go with float actually. Yep. So this is fine. So within the helper method handle request, let's simulate the request processing, right? So let's start with a simple if condition here. If duration, if duration is none actually, is none, then what we need to do here, let's set the duration, or let's assign the duration to random. Dot, let me make use of the uniform here. Yep. So let me pass from 0.1 to 0.6. Yep. So this is fine. Now let's go with time here dot sleep, time dot sleep of, let me pass the duration here. Let me pass the duration. This is fine. Finally, let me give the server dot release. Let me give the server dot release here. And finally, let's print something for the interactive purpose here. I'll just go with a print. So we'll be making use of the string interpolation here. So I'll just go with server. So this is fine. So let me make use of the server ID. So this one will be server dot ID. Hmm. Yep, server dot ID. Completed request. So this is fine. Request ID. This is also fine. And active. Let me go with active equals server dot server dot this one active connection. Right. So I'll just go with, this is not showing at all. So what is wrong here? So this one has to be parenthesis, right? So I have given here this one. Sorry, this is fine. So here instead of the this one. lar bracket I have to go with this one, and this one has to be server, not the successor actually. This is fine. Server dot active connections. Now it has to show, yeah, server dot active connection. So this is fine. We are done with this part actually. We are just printing this one for the interactive purpose. Next, let's do one thing. Let's move on with the health check cycle helper method. Yeah, so I'll just go with def actually. Health check cycle here. Let me pass self here. So this is fine. Let me pass self here. First thing is, let's go with a simple simulated health check, toggling a random server health, right? So I'll just go with a while here, while of true. This is fine. Let me go with lock here. So this is also fine. Server. Let me go with servers here. Go with servers, and let me assign this one to the list of server servers dot. Let me go with the values here, right? So this is fine. Yep. The next step would be, let's go with a simple for loop. Let's move on with the iteration here for S and basically we have to consider servers, individual server we are considering here. So let's randomly mark the servers unhealthy or healthy, basically, right? So I'll just go with if random uh, dot random again here. If it is less than zero point 0.2, if it is less than zero point 0.2, then I'll just give here s dot mark. Let me go with mark unhealthy first. So this is fine. And let's print something for the interactive purpose when unhealthy, right? So let's go with the string interpolation here. Health, this is fine. Server, let me go with s dot id. This is fair. Marked unhealthy. Marked unhealthy. Yep, so this is fine. Next, let me go with elif, not s dot healthy, and random, not random. This is fine. Let me set this one. If it is less than zero point 0.3 actually, then let's set this one mark healthy actually. Yeah, s dot mark healthy. This is fine. And again, for this one also, let's print something. This one basically for the interactiveness. Let me copy the same thing here. Let me paste it over here. So instead of unhealthy, let me take out un here. Let me give healthy instead of unhealthy. Now let's do one thing. Let's do one thing. Let's go with here. This one. Let's rebuild the weighted queue just to reflect the health changes, right? Same thing again with lock actually. Yep. So this is fine. Now I'll just go with rebuild weighted queue. So this is fine. This is fine. Next, let's set the this one time dot sleep here. Set this one to the 1.0 here. We are just going with a health check every second. Yeah. This is just for the demo purpose, right? So this is fine. Now let's come to the last helper method. Nothing but the snapshot. Let's come to the last helper method. Nothing but the snapshot. Yeah. This one of self actually. This is fine. I'll just go with lock. Yep. So let me return id. Just go with s dot snapshot here. So id is fine. Why this is showing here like this? S dot snapshot. So this is fine. Yep. For sid. Yep. Sn self dot. Let's go with the servers dot items, right? go with the servers dot items. Yep. So this is fine. We have to pass the parenthesis as well. Yep. Now this is fine, man. Yeah. So finally, yep, we are done with the coding part actually. Yep, we are done with the coding part. Or yep, we are done with the coding part. So this is it for the code actually, right? So two classes basically server and load balancer and number of helper methods as we had discussed on the UML diagram. Based on the UML diagram, I have explained everything why we'll be using certain things and other stuff. So I have explained this one almost every method, right? Um, every helper method or the function that we considered and the other stuff. What are the things that needs to be discussed? We have discussed this one step by step. Yeah. Now let's go with the demo usage actually. Yep. So let me take the demo usage from the Google. Just give me a second here. So let me come here. Let me copy paste this one. So demo, see here. So we are just calling the load balancer class here. So algorithm, we have initially set this one to the round robin. What we are doing here, we're just adding the three servers with different weights here, right? So LB dot this one add server, server one, server two, S2, this one server three, S3 here. So this is DNS we have given 10.0.0.1. Same thing goes with this one. The last number we have changed here 2 and 3. Weight we have set 1, 3, and 2 respectively. Yep. So this is fair, clean, and good. Yep. Now we are just starting the health check thread here. See here, HC equals threading dot thread here. Target we have just set this one to the health check cycle. We have already considered, and daemon we have set this one to the boolean value true, and we are starting the thread here. This is fine. Yep. Now we are simulating the client request. Initially we have set the request ID to 0. Now we are making use of the function client sim here, right? So non-local, this one request ID, this is fine. While request ID less than 25, then we are setting the different algorithm. Yeah, mid demo just to showcase the behavior. If request ID is 10, then we are making use of the this one equivalent to the 10. We are making use of the weighted round robin, and we are printing something for the interactive purpose. What if the request ID is exactly 18? Then we are going with the least connections, right? Least connections. We are going with the three algorithms basically. One is round robin. Second one is weighted round robin, extension to the round robin, nothing but the weighted round robin. The third one is least connections. Yep. So this is fine, I believe. Next, we are going with a route request here of request ID. Request ID, we are incrementing request ID equals request ID plus 1. Yeah. Sleep, we are this one we are going with we are setting or we are going with the new request every 80 milliseconds, right? So 0.08 we have set this one to 0.08, nothing but 80 milliseconds. Yeah. So this is fine. Client thread, we are just going with the thread. This is fine. We have set this one to the client sim target, and client thread we are just starting the thread actually, and we are giving join here. Finally, we are waiting briefly for outstanding request to finish. So sleep, we have set this one to 2, and final snapshot, this is for the interactive purpose. And finally, we are going with a SID, this one, nothing but the server ID info in the snap items, and printing, we are just printing the this one server ID along with the info, right? So this is it for the demo. This is it for the demo, right? Demo usage actually. Yep. So this is fine. We are done with the coding part. So accordingly, with the code that we have written or that we have discussed till now, actually, based on that we have written the code, right? So whatever we had discussed earlier, based on that we are this one written the code. So let me explain quickly what we have done here, right? So before checking the code, actually, right? Right, or before running the code, sorry. So we have went with a class server here. What it does, it holds the server metadata, active connection count, and per server log to safely update actually. Within this, we are going with actually where is this, one second. We are just going with the active connections and the total requests, right? We are just going with the active connections and the see total requests, so within the server. Then we are going with the helper methods, this one acquire, release, mark unhealthy, mark healthy, as well as the snapshot, right? So this is fine. Next, we are going with a load balancer class. So within the load balancer class, we are maintaining the server's dict and selection logic here. Nothing but add server or the remove server. So basically, they mutate pool under a lock, right? So we are going with a rebuild weighted queue here. Where is this one actually? This one helper method rebuild weighted queue. So this one constructs a simple weighted list for weighted round robin. Yeah, this is basically kept to avoid large list. Then we are going with the selected servers as well. So see here, select server, sorry. Then we are going with a select server as well. So basically select server implements three algorithms. Yeah, one is round robin, weighted round robin. Another one is this one, the final one, least connections, right? So either of the three algorithms, right? So this is fine. Next, um, next what we are doing, we are just going with a route request one. Yep, we are going with a route request, actually this part, this one. We are going with a route request. So here it selects a server, increments its active connection, prints route info and launches a worker thread to simulate processing, right? Then we are just going with a health check cycle, which simulates the health, this one toggles actually in real system. We have to replace this one with a HTTP or the TCP checks, right? So just keep this in mind. Snapshot, this one basically returns the current metrics. Snapshot basically returns the current metrics actually. This is fine. Finally, we are going with the demo usage. We have discussed this one just now actually. It builds a small pool actually, starts the health check, background thread, simulates 25 client requests while switching algorithms mid-run, right? So based on the request ID, right? So we are going with a round robin. If request ID is 10, then we are going with a weighted round robin. If request ID is 18, we are going with a least connections algorithm. Yep. So it basically demo builds a small pool, starts the health check, this one background thread, simulates 25 client requests while switching algorithms mid-run just to illustrate the behavior. At the endpoints, a snapshot of servers. At the end, sorry, prints a snapshot of servers, right? So this is the this one actually. What do we call? Um, this is about the code that we have written, right? So now let's run the code here. One second, let's run the code here. We are done with writing the code, right? So I'll just give here Python followed by, let me paste the file name here, file name.py, right? So we have, one second. So here it's actually saying self dot handle request. This is fine. Handle request. Object has no attribute handle request. So yeah, oh, okay. Where is this line number 122? 122, 122. This is 122. Yeah. So yeah, I have to remove this underscore actually. Yeah, we have just given handle request, right? Not underscore handle underscore request. So this is fine. Now this error has to be gone actually. We run this one, we will be will still have error. Oh, still have the error. Let's check what's wrong actually. So one more mistake in the line number 129 actually. It has to be 0 0.1, not the 0, 0,1 actually. So this is fine. Yep. So let's do one thing. Yeah, I'll just go with clear screen here. Yep. Yeah. Now we are getting this one correctly actually. Yep. This is fine, man. Yeah. See, the first one we are getting here, routed request 0. This one server 1, active equals 1. Yep, this is correct. So routed request 1, server S3, active equals 1. This one is fine. Yeah, this is correct itself, man. Yep, server is 1, completed request active. So this one you will see, we have set this one to the point 2, right? Somewhere, see here, this one if random we have set this one to less than 0.2, then we are marking unhealthy, right? So the server this one, basically else if in the else if we have written s dot healthy and random, if it's less than 0.3 actually, then we are marking that one as this one healthy actually, right? So this is fine. Switch to the weighted round robin here after this one. Switch to the weighted round robin when we are making use of the weighted round robin here. One second. This one. See here. Elif self-taught algorithm equals a weighted round robin. When we are making use of it. One second. this one here. If the request ID is equivalent to the 10, we are setting this one to the weighted round robin. If the request ID is equivalent to the 18. So these are with the this one from request ID 10, right? From request ID 10. See here, request 10, 11, 12, 13, 14, 15, 16, 17. Up to from 10 to 17, we have set this one to the this one weighted round robin. From 18 to the from 18 to 25, we have set this one to the what do we call least connections. Actually, we have yeah switch to the least connections. See here, routed request 18, 19, 20, 21, 22, 23, 24, 25. Right. So the finals this one what do we call until 24 we have this one server S1 marked healthy, server S2 marked healthy here, right? According to with what print this one we have written. So first this one is nothing but the see here server S2 marked unhealthy initially. So this is fine. Requested route 8 this one S1 active equals 1, routed request 9 S3 equals this one. So next we are switching to the weighted round robin again. Next we are switching to the least connections, right? When request ID is 10 to 17 we are going with this one weighted round robin. 18 to 25 we are going with this one what do we call least connections algorithm. Yep. So this is fine. Finally, we are going with a final snapshot. This one, based on what the code that we have written. See here, we are getting S1, ID S1, ID S2, server, nothing but this one, server S1, server this one S2, S3, ID. We have set this one to the S1, S2, S3. Address we have given. So this one, then DNS actually, 1, 2 as well as the 3. Weight we are getting 1, 3, 2 respectively. Active connections initially 0, 0, 0 here. Total request 12 based on this one whatever we have written based on the output that we got here. Total request 12, and for the server 3 this one total request 13. For the server 2 the total request 0 actually. Healthy, yes, all the three servers are healthy. So this is fine. S1, S2 and S3, right? So I hope this is clear, man. So we are getting the absolute desired output, right? As discussed, right? As I mean, whatever the code that we have written works absolutely correct, actually. Yep. So this is fine. And one more thing, just remember some of the points that I'll tell you. So whatever the demo that we have went with actually here, we are going with the demo, right? So the demo uses daemon threads, right? So we have made use of the daemon thread here. Somewhere there is this one. Yeah, daemon we have set this one to the true actually. Yeah, daemon threads actually for the background task to avoid blocking application exit. Yeah, health checks are this one simulated randomness. Health checks are simulated randomness. Replace with deterministic checks, HTTP or TCP probe actually in the production if you are making if you are going with the production, right? So weighted round robin uses capped expanded queue. This we have used a variable cap, right? If you remember, so you can just check. Weighted round robin uses a capped expanded queue for the simplicity. For the large weight ranges, we have to make use of the this one efficient algorithm, right? So weighted round robin counters or GCD based scheduling. We can just go with a weighted round robin counters or the GCD based scheduling, right? So this is fine, I believe. Now this is it for the code. Yep. So I hope whatever the code that we have written is completely clear, man. So this is it for the code. According to the UML diagram, we went with the code, right? So we had discussed based on what we discussed actually earlier, and based on the UML diagram, we have completely written the code, right? So, and we are also getting the desired output accordingly with the code that we have written. Now, let's do one thing. Let's discuss the limitations of the code that we have written, right? So just give me a second here. So, what are the limitations of the code that we have written actually? So, single process. When I say single process, this is an in-process load balancer, right? So, it does not handle multiple load balancing instances or persistent connection handling, right? So, I mean, it does not handle long-lived connections or proxies. Just remember this one. This is single process. The second one is it's simplistic weighted RR means here in this case we are making use of the list expansion that is capped at the 10 actually. This is very inefficient actually for the high weights or many servers, right? It's better if we implement the smooth weighted round robin, yeah, or arithmetic based this one weighted round robin. Yep. So next let's move on with the third one here, nothing but the health check. See, we are just going with a randomized demo. Uh, we went with a demo itself, right? We are just going with a randomized demo. Real this one health checks should be active TCP or the HTTP probes with a configurable timeouts and thresholds. We know this one. Yep. So let's move on with the fourth one here. No real network input output. When I say no real network input output, the demo just simulates request handling with a sleep actually. Yeah. Real forwarding would require socket or the proxy logic and connection pooling. Yep. So let's move on with the scalability. When I say scalability, least collection selection is big of n scan, right? For the large pools, we have to use a minimum heap or the minimum priority queue, or we can just go with the approximate consistent hashing or sharded pools, right? Or sharded pools, right? So this is fine. Now let's move on with the observability as well as the metrics. This one observability and metrics in the sense, so no integration with a metric system here, right? Whether it may be Prometheus, etc. Anything, right? So or structured logging. We are not going with a structured logging as well, right? So next one, let's move on with the session affinity here. Session affinity in the sense, so here basically we are not implementing session affinity, right? So we are going with the sticky sessions that requires consistent hashing or cookie based affinity. Yep. So this is one thing. Next, let's move on with the this one security and the TLS, right? So no TLS termination here, we know, and no authentication or rate limiting implemented here. We are just going with a pure solution. That's it. Yep. So next, the final one is the ninth one, nothing but fault tolerance. When I say fault tolerance, single load balancer is a single point of failure, right? Simple one. Single load balancer is always a single point of failure, right? Production requires multiple load balancers behind DNS or any cast and state replication if needed, right? If needed, we have to take care of it, right? This is fine. These are some of the limitations of the current code. Yep, let's finally move on with the alternate algorithms and the trade-offs, nothing but the trade-off summary here. This is related to the future discussions. So here, see, the first one is smooth weighted round robin. Yeah, the first one is smooth weighted round robin. Yeah, nothing but SWRR I have written. So we can just go with a smooth weighted round robin here. Alternative algorithms we are considering, right? We have instead of the main round robin or the weighted round robin or the list connections all go, we can just go with a smooth weighted round robin here. So this avoids the list expansion. It is better for high weights, right? Complexity would lead to big of logarithmic n or big of logarithmic 1, right? So complexity would lead to big of log n or this one big of 1 actually per request, right? Depending on the implementation, right? Trade-offs here, summary in the sense, this one, it's slightly more math, right? It uses slightly more math, but deterministic balancing, but uh, provides deterministic balancing. So this one. So next, let's go with the consistent hashing. So we can make use of the consistent hashing here. This is best for the session affinity, right? This is best for the session affinity as well as the cache locality. Yep. Trade-off here is it is less balanced when server set changes actually. It requires virtual nodes to improve the distribution. I'm speaking of the consistent hashing. Now let's move on with the power of two choices. Power of two choices, also known as POTC, right? So we can make use of the power of two choices here. We can pick two random servers here, route to the one with fewer connections, right? Again, a route to the one with fewer connections. It gives much better balance than the pure round robin with because of one overhead, because of one overhead. Yep, so this is fine. So this is good trade-off between performance and the complexity. Yeah, so this one we would have made use of. Then one more thing, we can just go with a weighted least connections. Weighted least connections in the sense we have to combine weight with the active connections, meaning effective connections equivalent to the active connections by weight actually, just to reflect the capacity part. Yep. So this is slightly more complex selection, right? It's slightly more complex selection. This is fine. Next, let's move on with the priority or the locality aware. When I say priority or locality aware, so we can route based on the geo latency tags. Yeah. So when we make use of the priority or the latency aware, so we can just route based on the geo or the latency tags. Just it adds the complexity in server metadata and also the selection logic. Let's move on with the final one here, the rate based or the token bucket. When I say rate based or the token bucket, it is for per server QoS, right? It is for per server QoS and client rate. This one client rate limiting. Yep, it requires counters and leaky bucket logic. It requires counters and as well as the leaky bucket logic. Right. So these are some of the alternative algorithms that we can think of along with the trade-offs, nothing but the summary. That's the future discussion. We have to keep this in mind while we are writing the code. So basically, round robin is the best one, and it's simpler. It also comes with certain cons, but for this, round robin is the best one. So I chose that one, round robin, weighted round robin, along with the least connections algorithm. Yeah. So this is it for this particular question. Actually, we have successfully designed a load balancer. We have successfully designed a load balancer. Just give me a second here. Yeah, we have successfully designed a load balancer here. So next, let's do one thing. Next, we'll be designing a this one logger system actually. Uh, I hope the coding part is clear, and I hope whatever the thing that we discussed is completely clear. Before coding, after the coding. After the coding, usually we discuss about the limitations of the code and future discussions, right? Along with the trade-offs actually. So that is fine. I mean, basically what are the algorithms we can make use of other than the algorithms that we have used in the this one along with the design patterns and other stuff. Yep. So we have to consider the design patterns, we have to consider the algorithms actually. What are the algorithms that we have to implement actually? What are the different algorithms that we have in that place that we can make use of in the future if something goes wrong? And we have to consider the data model and the concurrency part as well. That is also one of the important point. And before that, initially we have to go with the functional and non-functional this one requirements as well. Yeah. And yep. So whatever, when we ran the code actually, we have got the desired output, and I have explained that one. Yeah. So that's also fine. Yep. So now basically or primarily we are done with the designing a load balancer system. Yep. So next, as I've said, we'll be designing a logger. This one, what do we call, we'll be designing a logger system actually. For now, this is it. Thanks for watching, guys.